Okay, so in my presentation, I'm going to go over 3 parts. The first one, I'm going to share with you some basic, let's say, definitions, concepts, and to put you in context on the work that we are doing. In a second place, I'm going to introduce you the systems that we are implementing and starting to test. By list, I'm going to go over some few of the principal challenges that we might be facing ahead in this with this work. So first of all, the idea of digitalizing data is to make possible this idea of applying precision livestock farming and ranching ideas, right, in commercial situations. So what we understand as precision livestock farming is the management of livestock production using principles of technologies of process engineering, right? That's a nice definition. And it's based usually on the real-time automated monitoring of livestock and physical elements and processes related to production. So, and why we want to start implementing or bringing technologies into a ranching setting. So there are several reasons for why, and the more important ones that we can lay out is, of course, to try to capture opportunities for reducing the cost, impacts, and footprints associated with traditional animal and ranch monitoring. The second important aspect is going to be to seek new opportunities for more individualized animal monitoring assessments and management as well. A third opportunity or reasons for why technologies might fit into low input ranching systems is going to be to lower the demands and needs for physical labor, and while giving more quality time for other activities and tasks that are more important, right, for a rancher. Another opportunity is to capture and enhance animal welfare, animal well-being, and production in some of the cases. This 4 point has a very critical component. When we move into this idea of adopting technologies, in reality, the reason for change or improvement is not just on the technology itself, but on how we are using technologies to achieve the desirable goals. It's more important the how we are using it as opposed to what in reality we are using. Another important reason is to allow new opportunities for traceability, not only for products that we are obtaining from the ranch, but at the same time, from the practices and services that we can get from the ranch as well. And finally, to guide improvements in grazing management and resource use in many cases. Again, it's not about the technology itself, but about how we are using it. So just to give you a very quick overview on the context, the idea of digitalizing data and implementing that digital data into precision livestock farming is not a new idea and has been in the radar of farmers and ranchers for several decades now, right? But there is still some debate on, for example, how all of these digital data that we are collecting from the animals, from, let's say, the vegetation, and linking them into different visual dashboards that are telling us whether we are in green, yellow, red situations for different, let's say, KPIs or indicators of performance. There is still lots of debate on how they might apply in a low input system. And, and people are wondering whether, all of these, let's say, sensor work is sometimes an engineer's daydream or a nightmare or just an animal friend or foe or a farmer's panacea. There is more work that is really need to be done in order to start testing, how technologies might fit in low input ranching systems. Sensors are, of course, a very central element in any precision livestock farming or ranching situation. And there is a lot of, let's say, different varieties from data from traditional sensors and more, let's say, new emerging sensing techniques that we can get to get a full entire profile of data from our animals and in individual basis. Some examples could be the integration of three-dimensional accelerometers with traditional GPS tracking, but now in real time, and linking that with novel techniques that we can implement, such as the acoustics to get data on the feeding behavior and chewing behavior of those cows to classify the different activities and understand whether the cows are eating or grazing or ruminating, etc., or at the same time to be used as a proxy for estimations of feed intake in grazing conditions. We can also go into more in-depth detail on the metabolic profile of those cows by getting from remote locations an entire information of, for example, the ruminant gases that these animals are producing and emitting, and as well as the metabolic gases as carbon dioxide. We can use carbon dioxide as a proxy for estimations of feed intake in grazing situations, or as a proxy as well of feed efficiency, as people were discussing today, in situations where we cannot measure precisely the amount of feed animals are consuming. And then methane also, we can measure that remotely and have a better idea of the carbon footprint through enteric methane of the individual animals. The bottom line is that we can collect lots of data, right? And for example, in a pretty intensive farming situation, we can get up to 10,000 data points. Question is what we do with this. The key is to try to extract information from this rich database in the format of key performance indicators that are meaningful, right? Indicators that will be meaningful to track and to monitor production traits, changes in health, breeding, or parturition of the cows, right? That is a key, extracting from data meaningful information to drive decision-making. Important points to consider, for example, a critical aspect is to, the real value of a digital precision livestock farming platform could be realized when we start aggregating multiple streams of data to make our classifications or predictions even more robust. And here I will be sharing with you some data. This is research that was done on more intensive grazing scenarios with cows. But I will share with you some data on, for example, rumination collected from acoustics, activity through accelerometers, methane through spot samples of respiration, as well as carbon dioxide samples from respiration, and how they apply to help us produce some warnings, for example, of health, in this case, ketosis. In the x-axis, the days after calving for the cow, and in the y-axis, the different values for the response variables. First one, from acoustics, rumination, going down from day 0 all the way to day 4, then recovering, staying, and then dropping back again by day 16. After that, this blue arrow is when people were visually detecting that cow, doing interventions, and that cow recovers. Similar thing for activity. After calving, that cow drops her movement. She's not moving, she's not eating. There is some recovery by day 4, but that stays flat and drops back again by day 16. Same day when the cow receives treatment, she recovers back again and starts moving, eating, and doing well. Because that cow was not moving at the beginning, respiration gases, methane, and carbon dioxide will have a very similar profile. That cow was not eating. After day 4, she recovers, stays, but drops back again, in performance. By day 16, she's treated and recovers back again. So the idea is that the more streams of data we start aggregating, the better the resolution that we might have to predict outcomes, right? And to start using those outcomes for management purposes. Another important aspect is that there is no one silver bullet. There is no one sensor or type of data that is going to give us the entire profile of information that we might need in a ranching situation. And that's the reason for why we need to start thinking more in approaches that are site-specific and scale-dependent for biosensing, for the implementation of sensors to try to get a more complete spectrum of information in time and space and across animals to get a better understanding of what is going on, right? And a good example is, for example, and this applies for data we collect from vegetation and as well as from animals. But a good example, if we focus on the animal side, right, is, for example, we can implement low frequent GPS sampling to better understand movements and patterns at very large scale, as we've been seeing in the papers today in the morning. But at the same time, combining that collection, low frequency GPS data, with a very high resolution and intense collection of activity to get a better insight, for example, on activity and behavior in very short timestamps. So now I'm going to move into what we are doing right now in the project and how we are bringing digital technologies into the management of low input, right, extensive rangelands. The approach is to include and bring technologies of the Internet of Things to drive precision livestock ranching on rangelands. In this figure, what I'm sharing with you are the 4 basic elements of that approach, and then the conceptualization and model that is behind all of this integration. So the 4 critical elements, of course, it starts with the sensors. Those sensors need to communicate with some networking infrastructure. In this case, we are using LoRaWAN as communication. Sensors talk with a base station in here. This base station then sends the data to cloud services, either via Wi-Fi backhauling to the Ethernet location or just through cellular data. Once in the network servers, that information could be read and start being managed through different network controller devices that we can use to, for example, control for configuration of the sensors or retrieve some preliminary data. And then a very important step is to push all of these complex information, usually meaningless because it's raw data, into local servers and dashboard systems that will be able to read all of this complex data and pull out important, meaningful performance indicators, as I've been sharing with you earlier in the presentation. So the concept, the basic rationale and idea is that in a precision livestock ranching scenario, we have 4 critical elements: the collection of the data, the extraction of meaningful information from that data, and then the use of that information for decision support, and then to drive improvements in planning and management. As we move to the left of this conceptual model, we rely more on how well the sensor and the technology itself works. As we move more into the right of this conceptual model, it depends on how well we are using information and technology to drive management. Right? So sensors are not going to replace management, but are here to help us improve the way we are managing cows and rangelands, right? That is a very important concept to keep in mind. And the other one is that we need to be always output and objective focused. The idea is to bring technologies that fit our needs to reach objectives of gaining, for example, climate resiliency and sustainability. So the IoT concept, how this works, is a two-way communication between, let's say, the network services and servers and the devices that we are putting on the animals or in the ranch. So, for example, in this figure, I'm sharing with you water level sensors to continuously monitor water levels in drinking tanks or precipitation rain gauges, right, to monitor across the ranch different patterns of precipitation, or the trackers that we are mounting and using on the cows to monitor GPS and distribution as well as activity to get better insights on their behaviors, right? So we can, the communication is two-way. So there is an uplink and a downlink communication. We can quickly control for configurations of the sensors, and at the same time, we are collecting data from field sensors all the way into the servers and then dashboards. Among the components and sensors, of course, I've been telling you, we are tracking movements and movement and activity of the cow through different types of LoRaWAN trackers that we use on the cows. We are using sonic level sensors to monitor water levels, and then precipitation sensors to track different, let's say, precipitation patterns across the range. Another important element, of course, are the gateways. These ones are the ones that are collecting the information from the field sensors and pushing that information into the network controllers and cloud services. Important aspect is to keep in mind that we really depend on flexible base station infrastructure. We need to have technology that fit the needs and suit the needs in different locations and different applications. And that's a reason for why we are testing and troubleshooting and looking at for opportunities to start working on different strategies to communicate data from the field all the way into the servers, right, and dashboard later on. So here in these diagrams are two alternatives that we are looking at, is getting data from the field to this gateway and then sending from the gateway the data to the servers through Wi-Fi backhaul. Or the other strategy is just to use SIM cards, right, or for cellular communication directly from the gateways and sending through cellular technology the information to the cloud servers and dashboard applications. Right. Important as well is to understand how we are deploying this collection of data, right? And in these figures, what I'm sharing with you is the modeling strategies for the LoRaWAN signals that are telling us how well our deployments of the antennas and gateways in the field are picking up the signals, right, and communicating with the different, let's say, sensors. So the darker, the blue here, the light blue is a good signal, the better signal, then the dark blue is an average medium signal, and then the pink is a low quality, let's say, collection signal for the LoRaWAN, right? And this is the same branch that recently Matthew was sharing with you some of the data that we are collecting at the same time with the criollo cows. This is an example of, for example, here we have the combination of strong signals, then medium average signal, and then a poor communication signal in pink. And you can see here in the dots, the points, the collection of the GPS of cows across all of these range. And usually we get empty pockets here of data in areas where we have lower coverage as well. So it is very important to think in a good infrastructure to collect data. Another critical or central element is going to be on the dashboard side. It is important that all of the collection of this data ends into a format that is useful, right, for ranchers and for users. The dashboard development is a central element for our project, and we are working on creating a dashboard that could be used to, for example, manage the data from the cows on the ranch, to keep up with inventories, to visualize the location of the cows, to know where the cows are. So we want to know inventories, where the cows are, and how well they are doing, right? Through activity and through analysis of GPS and movements. And we are also testing other sensors and incorporating other streams of information. So in this example and yesterday, there was a really good presentation on this work on how we are incorporating three-dimensional deep cameras, right, to get better insights on body condition scores and using machine learning approaches to read all that information, right? Important is to translate this into applications with ranchers, and that is the reason for why we are engaging into collaborations with different ranchers across the Southwest. We are looking at testing sites here in the Utah, as well as in Southern California, and our sites as well in here in New Mexico. So just to conclude, what are the potential challenges we might be facing ahead? So the first and more important one is that the potential benefits we really need to get tested in commercial applications, in ranches. In a second place is that we see that the independent testing and availability of commercial precision livestock ranching systems is pretty limited right now. And there are uncertainties and knowledge about precision livestock technologies and tools and how well they might suit the needs of low input ranching systems. Also, we notice that the providers of precision livestock ranching services is still limited today, and there is a need for more entrepreneurial work and initiatives within the private sector and universities as well to support further development of these technologies. And the last final point, I think, is an important reflection that precision livestock may not be a solution for all of the ranchers. Some ranchers may need some applications while other ranchers may need others, right? But it's very interesting how fast the technology is moving, right? And the offers that we are seeing out in the market, right? So for example, people are looking at aerodynamics of cows at this point, right? The question is, what is the application perhaps for areas with more wind? I don't know, but you know. So with this, I will finish my presentation, and I would really like to thank you for your attention and then for the organizers of this symposium. Thank you.